Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be talking a little bit about hot and cold streaks and introducing the idea of the gambler's fallacy. So, inspiration. We had the NFL playoffs starting last weekend, Saturday through Monday. So during that regular season, the Dallas Cowboys kicker Brett Maher went 50 of 53 on extra points. So after you score a touchdown, your team has a chance to kick a field goal type thing for one extra point. During the regular season, he went 50 of 53, approximately 94% on those extra points. Last Monday, however, during the first game of the playoffs for the Dallas Cowboys, he missed his first 4 extra points. He actually set an NFL record for the most missed extra points in a game. He ended up 1 of 5 for the game. Luckily for him, the Cowboys won, so his team still won, even though he was much worse than normal on his extra points for that game. Now, don't want to be rude or anything, but let's do some quick math here just to explain how unlikely, quote unquote, unlikely this would be if we're assuming he has that 94% chance of making an extra point, right? He kicked a lot of extra points during the season. He made them at a 94% clip, meaning that for any kind of given extra point, we could assume he has a 6% chance of missing that extra point. And if he's going to miss 4 in a row, it's pretty easily 6% times 6% times 6% times 6%. So this would be raised to the 4th power there. Now, I want to make sure that I have this correct here. So this is approximately 0.001296. And before that seems too low, yes, this answer is also in a percent. So it's 1/1000th of a percent approximately. Or as a fraction, this is approximately 1 in 77,000. So we have this 1 in 77,000 chance, roughly, that he actually would be missing 4 of these in a row. Now, the crux of this is what we're going to start talking about on the next slide. So in this calculation, in this 1 out of 77,000 thing, what assumptions are we making there? Right? And so there's a lot of different things that you could say we're assuming. We're assuming that during the regular season, this was his true extra point percentage, the true kind of skill he had at picking the extra points, things like that there. But the main assumption we're making is that all of the kicks are independent. So this is a good word to be reminded of in probability, things like that there. This just means that the kicks or the events do not affect each other. So events do not affect each other. And that kind of is an important assumption in certain scenarios. We're going to be talking about situations like this in a little bit. If you roll a die, right, rolling the die doesn't affect other dice rolls. Coin flips don't affect other dice rolls or other coin flips there too. Now, in this case, is this assumption true? Probably not. Right? And this is getting into some of the interesting stuff we'll talk about later with this hot or cold streak type of thing. Right? Oh, if he missed one, does that make him, you can make the case both ways. Now, maybe he's stressed, now he's less likely to make the next one, or maybe he's more focused, and now the next one he has a higher chance of making. His whole team affects these things as well. It's not just the kicker. Somebody snaps the ball, holds the ball before it's kicked. These things are a lot more complicated there. But even thinking about this, do the events affect each other? Probably not in this case. And so that's the thing here that is important to keep in mind between these sport examples we're going to look at versus something like a coin flip or a dice roll or the probability of winning a game of roulette, or kind of if you're doing blackjack where you're not allowed to count cards or they shuffle after every hand, right? All of those things then would be independent events there. And that brings us to this stressing of the independent events, this idea of the gambler's fallacy. So suppose you're flipping a coin, and so far you've seen something like HHH there, right? And the question then is the next flip more likely to be heads or tails? Now, want to highlight a few important things we have here, right? We are assuming that we know we have a fair coin in that case. So it's an interesting question, but not one we're thinking about now is, oh, if you've seen HHH, should we start questioning whether it's a fair coin or not? We're assuming it's a fair coin in this scenario. And the other thing that's important here, right, which I'll come to in a second, right, is that we do have this fair coin. This could also work for rolling of the die, things like that there. Why is that important? It's a fair coin, and then this is telling us that those coin flips are independent from each other. Anytime we have a coin flip or things like that there, that's our information, meaning that our answer should be neither, right? They are equally likely. And that's the important thing we have here. Now, that is the true answer, right? This is no fallacy or anything. Nothing I've written down right now is incorrect. Nothing is false about this. So what is the gambler's fallacy, right? The gambler's fallacy is something like it's unlikely to see a lot of H's in a row, so now tails should be more likely, or something like that, right? We know on average we should have the same number of heads as tails, so if we see a bunch of heads in a row, that means the next tails should be more likely in that case. Now, just to stress a little bit or clarify something like this here, right? I want to break this down into the two parts of the sentence there. So this first part of the sentence, it's unlikely to see a lot of heads in a row. I just want to clarify and not confuse anyone. This is true. This is totally true. We don't expect, it's not very likely to see a lot of heads in a row. If you were betting from the beginning, if the gambler was saying, oh, do you think it's going to be HHH in the next 3 coin flips? You should say, no, I don't think that should be true. However, this next part, right, you cannot make the conclusion because of our independence things that now tails should be more likely. This is the part of that statement that is false. So that's what you need to be careful about for the gambler's fallacy and things like that there. So that is set in stone. For independent events, we know that this gambler's fallacy is false. You're not more likely to have tails after seeing some heads. You're not more likely to see more heads, right? Either way you do this, it does not affect the later outcomes. That is the definition and the meaning of independence. Now, what about this idea of a hot streak or a cold streak? Or a lot of the times this is actually talked about in the positive fashion with this idea of a hot hand. So remember, independent events, we have this idea of the gambler's fallacy. You're not more or less likely to get a heads or tails on a fair coin, regardless of what happened before there. Now, what about things that are not necessarily independent? We introduced this with the idea of NFL kickers with extra points. This has actually been studied more, which we'll talk about next week, in terms of NBA players shooting jump shots or things like that there. So in particular, this idea of the hot hand is really popularized by the video game NBA Jam. But this is something that really had been going around in the circles for a long time, right? You would say an NBA player is hot or feeling it or on fire. So in the video game, a player would literally become on fire, the ball would start flaming and things like that there. And this meant that you were more likely to make the next shot. So this is the opposite of maybe what was going on with the NFL extra point kicker, where he was missed it and then missed again. Something maybe snowballed a little bit there. There was this cold streak. Here we're talking about this idea of a hot streak. So if we're saying, okay, they hit a shot in a row, or maybe a couple in a row, is the probability higher than normal to make the next shot here? That's this idea of somebody having a hot hand or being on fire or something like that. They make a shot. Is the next shot they make kind of going to have a higher probability than their normal shooting percentage? So, question one of the week is consider ways to test this idea of the hot hand. How could you go about doing this or thinking about it there? For example, right, if you had data such as shots made or missed in order, right? So you have an NBA game, you look at one player, every shot they took, make or miss, right? How might you start collecting data over multiple games to determine if this hot hand idea is correct or incorrect there? Now, with that in mind, and this is something we're going to talk more about next week, let's think about a complication here, or that's a little bit of a spoiler, but think about a simulation. So simulate this could be done by kind of flipping a coin. You flip a coin, okay, heads is a make, tails is a miss. So this would be assuming somebody has a 50% chance of making a shot, and we can look at these coins, heads and tails there. So we would expect 50% of the shots to be made, right? And then I want to have you do this with your answer to one, right? So think about how you might try to determine whether a hot hand exists or not. And then look at this for coin flips. So, okay, flip the coin a bunch of times. Are you more likely to get another head after a head? Does this probability, is it more than 50, less than 50, still 50, right? Is that evidence or non-evidence for your hot hand there? And spoilers, this is a little bit more complicated than you might think, which we'll talk about more next week. Last little thing, one simple way to collect, right? If I don't actually want you to flip coins or things like that, websites like Wolfram Alpha, I'll put a link below with this direct query. If you type something like 50 coin flips there and scroll down a little bit, it'll give you some stats before that. But they have this example where you could see, okay, they randomly flipped 50 coins. We could use something like this to simulate 50 shots. You can click the flip again button if you want another random set of outcomes or things like that there as well. So we'll continue this topic next week. This really gets into some interesting / complicated statistics ideas, probabilities ideas. So we're only going to scratch the surface a little bit there, but stay tuned next week. If you have some questions, let us know in the comments below. We can definitely use those to change up next week's video or try to answer some of those questions along the way as well. Otherwise, if you enjoyed this video, please give us the like. Please subscribe for new videos each week and other content from us at Areteem. Otherwise, I will see you all next time. Goodbye.